Hello, good day everyone. Today I am going to discuss my assignment for the subject of refrigeration. But first, I am going to introduce myself. My name is Kenneth Alimpag from IBSU Ormoc City Campus. Number 1. Ammonia vapor refrigeration cycle. Given. Evaporation temperature equals 16 degrees Celsius. Con- Condensing temperature is 32 degrees Celsius, while the H1 equals to Hg at 16 degrees Celsius is equals to 1442.6 kilojoules per kilogram, while the S1 equals Sg at 16 degrees Celsius is equals to 5.842 kilojoules per kilogram Kelvin, while the H3 equals Hf at 32 degrees Celsius is equals to 351.466 kilojoules per kilogram, while evaporation pressure is equals to 1239.6 kPa. Then H2 at evaporation pressure and S2 is equals to S1 is 1685 kilojoules per kilogram. Solution. Ideal COP is equals to H1 minus H3 over H2 minus H1. Substitute 1442.6 minus 351.466 over 16 or 1685 minus 1442.6. The answer is 4.501377888 or 4.50. Nya makancel man ang given ana. So mo na wala siya given. Number 2. Evaporation temperature is equals to negative 25 degrees Celsius and 20 tons, and condensing temperature equals to 41.6 degrees Celsius. At evaporation temperature is equals to negative 25 degrees Celsius, mag-interpolate para makuha ang H2, ang S1 o ang V1. Then, let the 24 negative 24 negative 24 is T1, then let the negative 25 is T2, and let the negative 26 is T3. Nya iya formula is kuan T1 minus T2 over T1 minus T3. So, i-substitute negative 24 minus negative 25 over negative 24 minus negative 26 is equals to 340.876 minus Hg1. Well, iwa mo sa G1, then over 340.876 minus 339.908 is equals to 340.422 kilojoules per kilogram. Nga, pagkuha sa S1, same ra gyapon ang formula, i-substitute negative 24 minus negative 25 over negative 24 minus negative 26 is equals to 1.56985 minus S1 over 1.56985 minus 1.57152 is equals to 1.570685 kilojoules per kilogram Kelvin. Yung pagkuha sa volume, mao gyapon ang formula, then substitute lang negative 24 minus negative 25 over negative 24 minus negative 26 is equals to 126.282 minus the volume 1 over 126.282 minus 136.284 is equals to 131.283 liter per kilogram. Then, at condensing temperature is equals to 41.6 degrees Celsius. Yeah. I-interpolate gyapon para makuha ang condensing pressure o ang H3. Ang pagkuha kay same ra gyapon ang formula. Then substitute 42 minus 41.6 over 42 minus 41 is equals to 1008.8 minus condensing pressure over 1008.8 minus 984.51 is equals to 999.084 kPa. Then pagkuha sa H3, mao ra gyapon i-substitute lang 42.41.6 over 42.41 equals to 240.57574 minus HF over 240.574 minus 239.552 equals 240.1652 kilojoules per kilogram. Then, H2 at condensing pressure and S2 is equals to S1. Then, H2 is 377 kilojoules per kilogram. Yeah, solution. A. To solve the refrigerating effect, ang iya formula is QA equals H1 minus H3. Then substitute sa given ganiha sa ato na cup up atong interpolation, man i-substitute na lang 340.422 minus 240.1652 kilojoules per kilogram is equals to 100.2568 or 100.26 kilojoules per kilogram. Then letter B is to solve the refrigerating capacity, ang iya is 20 tons times 3.52 kilojoules per second over TR. I-convert na siya, ang iya answer is 70.4 kilojoules per second. Nya, pagkuha sa sa M is equals to refrigerating capacity over H1 minus H3. Yeah, substitute na lang iya na may given iya refrigerating capacity which is 70.4 kilojoules per second, then ang H1 minus H3 na nasad siya given which is the 100.200.26 kilojoules per kilogram. Yeah, i-cancel ang like terms is equals to 0.7021743467 or 0.702. Letter C. To solve the work is equals to mass times H2 minus H1. Yeah, substitute the mass 0.7022 or 0.702 times H2 which is 377 minus H1 340.422 kilojoules per kilogram is equals to 25.6850716 kilojoules per second or 25.69 kilowatts. Letter D. To solve the COP formula is equals to H1 minus H3 over H2 minus H1. Yeah, i-substitute since nakuha na masad na ang H1 ug minus H3, i-answer kay 126 kilojoules per kilogram over the H2 minus H1 377 minus 340.422 kilojoules per kilogram. Cancel ang like terms. The answer is 2.740991853 or 2.74. Letter E. To solve the total head rejected, formula is QR is equals to M times H2 minus H3. Mass is 0.7022 kilogram per second times 377.240 377 minus 240.1652 kilojoules per kilogram. Cancel ang kilogram na mabili na lang kay kilojoules over second. Then the answer is 96.08539656 kilojoules per second or 96.09 kilowatts. To solve the volume is equals to mass or MV mass mass is 0.7022 kilojoules per kilogram times 131.283 liter per kilogram. The answer is 92.1869226 or 92.19 liter per second. Number 3. Given ammonia. Condensing temperature is equals to 35 degrees Celsius. Then the ref mass is equals to 3.84 kilogram per minute. Work mass is equals to 120 kilogram per minute. Condenser W1 is equals to 30 degrees Celsius, while the condenser work sub-zero equals to 40 degrees Celsius. At condensing temperature is equals to T3 equals 35 degrees Celsius. The pressure 3 is equals to 1352.2 kPa. And then the H3 is equals to 366.072 kilojoules per kilogram. Ang H4 is equals H3 equals 366.072 kilojoules per kilogram. At condenser QH2O equals QREF. The formula is mass of water times specific CpH of water specific pressure of water times T0 minus T1 equals M ref mass times H2 minus H3. Then substitute. Since minute man siya, ato siya i-convert into second. 120 kilogram per minute over 60 seconds per minute times 4.187 kilojoules per kilogram Kelvin times 40 minus 30 degrees Celsius is equals to 3.84 kilogram per minute over 60 seconds per minute times H2 minus 366.072 kilojoules per kilogram. Then the answer is H2 equals 1674 or 1674.5095 kilojoules per kilogram. While P2 is equals P3 is equals to 1352.2 kPa. Then S2 is equals to 5.755 kilojoules per kilogram Kelvin. Then ang S2 is equals S2 equals 5.755 kilojoules per kilogram Kelvin. H1 equals Hg equals 14 or 1450.22 kilojoules per kilogram. Then ang pressure 1 equals to 291.57. Then ang T1 equals or temperature 1 equals negative 10 degrees Celsius. Solution. Letter A. To solve the refrigerating capacity, the formula is M times H1 minus H3. Substitute. The mass is 3.84 kg per minute times the H1 1450.22 minus the H3 366.072 kilojoules per kilogram. Your answer is 4163.12832 kilojoules per minute times convert siya into TR times TR over 211 kilojoules per minute is equals to 19.73046.597 or QA or refrigerating capacity is equals to 19.73 TR. B. To solve the COP, the formula is COP equals H1 minus H3 over H2 minus H1. Substitute na sad 14 or 1,450.22 minus 366.072 kilojoules per kilogram over 1,674.5095 minus 1,450.22 kilojoules per kilogram. Since parehas mo sila term, pwede rin makancel. The answer is 4.8336999304 or 4.83. Letter C. Work equals M or mass times H2 minus H1. Substitute yung mass 3.84 kg per minute time over ay minute man siya, i-seconds na to. Over 60 seconds per minute times 1,674.5095 minus 1,450.22 kilojoules per kilogram. Yung answer is 14.354528 kilojoules per second times i-convert into HP times 1 HP over 0.746 kilojoules per second. And the answer is 19.24199464 or 19.24 HP. Number 4. Given ammonia 20 TR. Condensing temperature is equal to 32 degrees Celsius and evaporation temperature is equal to negative 14 degrees Celsius. At T1 or temperature 1 equals negative 14 degrees Celsius, then H1 is equals to Hg is equals to 1445.2 kilojoules per kilogram. S1 equals to Sg equals 5.8125 kilojoules per kilogram Kelvin. Then the pressure 1 equals 247.14 kPa. At temperature 3 equals 32 degrees Celsius. Then H3 is equals to Hf is equals to 351.466 kilojoules per kilogram. Condensing pressure is equals to 1,239.6 kPa. Then S2 is equals to S1. Then S1 is equals to 5.8125 kilojoules per kilogram Kelvin. H2 at condensing pressure and S2 is equals to 1,685 kilojoules per kilogram Kelvin. Solution. A. To solve the refrigerating effect, formula is Q, small letter Q, A, E equals H1 minus H3. Then substitute 1,445.2 minus 351.466 kilojoules per kilogram is equals to 1,093.734 kilojoules per kilogram. Then letter B, to solve the refrigerating capacity, convert (20 TR) times 211 kilojoules per minute over 1 TR is equals to 4,220 kilojoules per minute. Then mass equals refrigerating capacity over H1 minus H3 equals 4,000. Substitute the refrigerating capacity is 4,220 kilojoules per minute, and ang answer ganiya sa H1 minus H3 is the 1,093.734 kilojoules per kilogram. Then cancel the like terms. The mass is equals to 3.8583342156 or 3.86 kilogram per minute. Then letter C. W equals mass times H2 minus H1. Then since minute ato na sa di convert into second. Ang mass is 3.86 kilogram per minute over 60 seconds per minute times 1,685 minus 1,445.20 kilojoules per kilogram. Cancel ang like terms. Answer is 15.42713333 or 15.43 kilowatts. Letter D. COP. To solve the COP, formula is COP times H1 minus H3 over H2 minus H1. Substitute. (1,445.2) minus 351.466 kilojoules per kilogram over 1,685 minus 1,445.2 kilojoules per kilogram. Cancel ang like parehas term. Answer niya kay 4.56102585 or 4.56. So letter E. Work mass or MW equals mass times H2 minus H3 over CPW times the change of temperature. Substitute. Mass is 3.86 kilogram per minute times 16.85 minus 351.461 kilojoules per kilogram over 4.187 kilojoules per kilogram Kelvin times 8 degrees Celsius. Cancel ang parehas. The answer is 153.6733114 kilogram per minute times i-convert to GPM times og 2.205 pound over 1 kilogram times 1 gallon over 8.33 pound. Then the answer is 40.6378225 GPM. Sa letter F, X4 or is equals to H4 minus HF over HG minus HF is equals to 351.466 minus 135.820 kilojoules per kilogram over 1,445.20 minus 135.820 kilojoules per kilogram. Cancel ang para sa term. The answer is 0.1646932136 or 16.47%. So letter G, H2 equals 1685 kilojoules per kilogram and pressure 2 is equals to 1,239.6 kPa. Ang answer is using the chart. Ang temperature 2 is equals to 102 degrees Celsius.
Number 5. Given ammonia 15.25 times 15.25 centimeter. N is equals to 450 RPM. Temperature 1 is equals to negative 18 degrees Celsius. Pressure 3 equals to 1514.3 kPa. Yan. Ice temperature is equals to negative 10 degrees Celsius. Then the water temperature is equals to 27 degrees Celsius. And efficiency, VA efficiency equals 78%. Then C efficiency equals 82%. Then mass efficiency is 88%. At temperature 1 is equals to negative 18 degrees Celsius. Then the pressure 1 is equals to 208.26 kPa. H1 is equals 1439.94 kilojoules per kilogram. Then S1 is 5.8720 kilojoules per kilogram Kelvin. And the volume is 572.875 liter per kilogram. Then at pressure 3 is equals to 1514.3 kPa. Then temperature 3 equals 39 degrees Celsius. H3 equals 666 kilojoules per kilogram. H2 at pressure 3 and S2 is equals to S1. Then S1 is equals to 1745 kilojoules per kilogram. Solution. VD equals pi over 4 times diameter squared times length times N. Yeah. Ang equivalence D is 0.1525 meter. Yan sa length. 0.1525 meter. Yan sa N is 450 times 2. VD equals niya i-substitute pi over 4 times the diameter squared 0.1525 squared times 0.1525 meter times 450 times 2 is equals to 2.50693 cubic meter per minute. VA efficiency is equals to V1 over VD equals then substitute 0.78 equals V1 over 2. The VD 2.50693 cubic meter per minute. Then answer is 1.9554 cubic meter per minute. Then volume rate V1 minus is equals to mass times specific volume equals mass. We derive mass times volume flow rate over specific volume. Substitute 1.9554 cubic meter per minute over 572.875 liter per kilogram times convert times cubic meter over 1,000 liter. I-cancel lang parehas ang term. The answer is 3.413 kilogram per meter. So, letter A. To solve the refrigerating capacity, ang formula is M times H2 minus H3. I-substitute, the mass is 3.413 kilogram per minute over, since minute A ato is second, ato siya divided og 60 second per minute times 1439.94 minus 385.666 kilojoules per kilogram is equals to 59.97061,937 kilojoules per second times, and convert into TR, times na to 1 TR over 3.52 kilowatts is equals to 17.03710777 or refrigerating capacity is equals to 17.04 TR. Letter B. Work equals M times H2 minus H1. Substitute the mass 3 niya i-convert into second 3.413 kilogram per minute over 60 seconds per minute times the H2 1745 minus 1439.94 kilojoules per kilogram is equals to 17.3528 kilowatts. C efficiency is equals to work in over indicated work. Substitute 0.82 is equals to the work 17.3528 kilowatts over indicated work is equals to indicated work is equals 21.162 kilowatts. Solve the M or mass efficiency is equals to indicated work over brake work. How to solve the brake work day? Yeah. You derive brake work is equals to indicated work over M efficiency. Substitute 21.162 kilowatts over 0.88 yan ang answer is brake work equals 24.0477 kilowatts. You convert into HP times 1 HP over 0.746 kilowatts. Cancel. Yeah, the answer is brake work equals 32.24 HP. So letter D. The ideal COP equals, to solve the ideal COP, the formula is H1 minus H3 over H2 minus H1. So, substitute 1439.94 minus 666 kilojoules per kilogram over 1745 minus 1439.94 kilojoules per kilogram. I-cancel ang parehas sa term. The answer is ideal COP equals 3.455956205. So, number 6. R212 refrigerant. Evaporation pressure equals 386 kPa while condensing pressure equals 1009 kPa. Then the decreased pressure equals 270 kPa. At evaporation pressure equals 380 kPa, the temperature 1 is equals to 7 degrees Celsius. The H1 is equals to 354.439 kilojoules per kilogram. Then the S1 equals to 1.55133 kilojoules per kilogram Kelvin. Then the volume is equals to 0.0447129 cubic meter per kilogram. Then times 1,000, 44.719 liter per kilogram. Okay, convert mo siya into from meter cubic or cubic meter into liter. Then at condensing pressure equals 1009 kPa, it has temperature 3 equals 42 degrees Celsius. The H3 is 574 kilojoules per kilogram. At H2 at pressure 3 and S2 is equals S1, then S1 is equals to 372 kilojoules per kilogram. Then at H2 prime pressure 3 and S2 prime is equals to S1 prime, then S1 prime is equals to 375 kilojoules per kilogram. Solution. Letter A. Refrigerant effect for unit mass. At pressure 1 is equals to 386 kPa, the refrigerating effect is equals to H1 minus H3 is substitute equals 354.439 minus 240.574 kilojoules per kilogram is equals to, the answer is the refrigerating effect is equals 113.865 kilojoules per kilogram. Then at kuan naman at pressure 1 prime equals to 270 kPa. Yeah, same formula. Substitute 349.755 minus 240.574 kilojoules per kilogram. Then answer, refrigerating effect equals 109.181 kilojoules per kilogram. Then the refrigerating effect per unit mass is decreased. Letter B, COP. At pressure 1 is equals to 386 kPa, the COP is equals to H1 minus H3 over H2 minus H1. Then substitute 354.439 minus 240.574 kilojoules per kilogram over 372 minus 354.439 kilojoules per kilogram. Then answer, COP is equals 6.4839706161. Then while at pressure 1 is equals to 270, pressure 1 prime is equals to 270 kPa. Yeah, COP is equals to H1 prime minus H3 over H2 prime minus H1 prime is equals to, substitute 349.755 minus 240.574 kilojoules per kilogram over 375 minus 349.755 or 755 kilojoules per kilogram. Then answer is COP equals 4.32485647. Then the COP is decreased. Then letter C. Letter C. Work at P1 is equals to 386 kPa. Work is equals to H2 minus H1 equals, then substitute 372 minus 354.439 kilojoules per kilogram. Then ang answer is work equals 17.561 kilojoules per kilogram. While at P1 pressure 1 prime equals 270 kPa, work is equals to H2 prime minus H1 prime is equals, substitute is equals to 375 minus 349.755 kilojoules per kilogram. Then the answer is work is equals 25.245 kilojoules per kilogram. Then the work per unit mass is increased. Letter D. Power. At power 1 equals 386 kPa or pressure 1 is 386 kPa. COP is equals to refrigerating capacity over work. Work is equals to kilonewton over 6.48. Then is equals to work is equals 0.1543 kilowatts. While at pressure 1 prime is equals to 270 kPa, the COP is equals 4.325. Then the COP is equals to refrigerating capacity over work. Work is equals to kilowatts over 4.325 or work or kilowatts over COP. 4.325 is equals to work is equals 0.2312 kilowatts. Then the power is increased. Letter E. Mass flow rate. At pressure 1 is equals to 386 kPa. The mass is equals to refrigerating capacity over H1 minus H3. 1 kilowatts over the the answer of H1 minus H3 is equals to 113.865 kilojoules per kilogram. Then, ang answer, mass is equals to 0.0087 kilogram per second. While at while at pressure 1 prime equals 270 kPa, mass equals to refrigerating capacity over H1 prime minus H3 is equals to 1 kilojoules per second. Then, ang answer sa H1 prime minus H3 is equals to 109.181 kilojoules per kilogram. Then, ang answer is mass equals 0.009159 kilogram per second. Then, the mass flow rate increase. Letter F. Heat rejected. At pressure 1 is equals to 386 kPa, mass is 0.00878 kg per second. The total heat rejected is equals to M, our mass times H2 minus H3. Then substitute, mass is 0.00878 kg per second times 372 minus 240.574 kilojoules per kilogram. Then, ang answer is total heat rejected equals 1.1539 kilowatts. Then, while at pressure 1 prime equals 270 kPa, mass is equals to 0.009159 kilogram per second. Then, QR is equals to mass times H2 prime minus H3. You substitute, the mass is 0.009159 kilogram per second times 375 minus 240.574 kilojoules per kilogram. I-cancel ang parehas ng term. Yung answer is total heat rejected is equals 1.2312 kilowatts. Then, the heat rejected is increased. Then letter G. Volume flow rate. At pressure 1 equals 386 kPa with a mass of 0.0878 kg per second with a volume of 44.7129 liter per kilogram. Volume flow rate is equals to mass times specific volume. 0.00878 kg per second times 44.7129 liter per kilogram is equals to, ang answer is volume flow rate equals 0.3926 liter per second. While at pressure 1 prime equals 270 kPa with a mass of 0.009159 kg per second with the specific volume 1 prime equals to 62.8952 liter per second. Volume flow rate is equals to mass times specific volume 1 prime. Substitute 0.009159 kg per second times 62.8952 liter per kilogram. I-cancel ang parehas ng term. Ang answer is volume flow rate 1 prime equals to 0.5761 liter per second. Then, the volume flow rate is increased. Number 7. Given 4-cylinder with the diameter of 0.076 meter, length of is equals to 0.102 meter. Then speed of 800 RPM. R212 refrigerant condensing temperature equals to 300 or equals 38 degrees Celsius. Evaporation temperature equals 7 degrees Celsius. The temperature 1 prime equals 13 degrees Celsius. Then the V efficiency is 0.7. Then temperature 4 equals 5 degrees Celsius. Then to solve the VD equals pi over 4 diameter squared times length times n. At condensing temperature equals 32 degrees Celsius with pressure 3 equals 914.23 kPa with H3 equals 236.510 kilojoules per kilogram. At evaporation temperature equals 7 degrees Celsius with a pressure 1 equals 386.01 kPa with H1 equals 354.439 kilojoules per kilogram with the volume equals 0.044729 cubic meter per kilogram. At temperature 1 prime equals 13 degrees Celsius with a pressure 1 prime equals P1, then P1 equals 386.01 kPa, then H1 prime equals 356.918 kilojoules per kilogram. And the volume 1 prime equals 0.0374991 cubic meter per kilogram. Nya isolve ang kuan VD, formula is pi over 4 diameter squared times length times n. Nya substitute pi over 4 times 0.076 meter squared times the length 0.102 meter times 800 RPM times 4 cylinder is equals to VD equals 1.4807 cubic meter per minute. And V efficiency equals V volume over VD. Nya substitute 0.7 equals V1 over the VD 1.4807 cubic meter per minute is equals to the volume of equals to 1.0365 cubic meter per minute, and mass is equals to volume 1 over volume 1 prime equals 1.03365 cubic meter per minute over 0.0374991 cubic meter per kilogram. Ang answer is mass is equals to 27.64 kilogram per meter per minute. Then the refrigerating capacity is equals to mass times H1 minus H3. 27, then substitute 27.64 kilogram per minute over 60 second per minute times 354.439 minus 236.510 kilojoules per kilogram. I-cancel ang first term, then ang answer is refrigerating capacity is equals 54.33 kilowatts.